So go ahead, Owen.
Okay, thanks a lot, Nancy. Great, so in part one, we talked about the things that have changed in Datacom, particularly with the zip and things like that, that have changed the way that we do tuning and the things that we can do to tune the application without actually changing any code. In part two now, we're going to look more specifically at some things that we can do within the code to improve the performance of that. And I'm going to talk about various different methods, whether it's ideal, metacobol, COBOL, other things that we can look at in order to improve it. So we'll look at the application tuning within the application. We'll talk a bit more about the URT and how it can affect the application performance. Ideal programming recommendations, tuning tools that we have available to us, and a summary, and some general programming recommendations that we have that are across the board, doesn't matter which platform that we have. Okay, so some application issues need to be resolved within the application. In other cases, we can use new or different programming techniques to improve the application's performance. So I remind people now that, again, traditionally people view the mainframe as green screen and batch and some historical thing that can only do those processes. Nowadays, with the new interfaces that we have, web services, ODBC, JDBC access to the database, even RESTful APIs that can talk to Datacom. You're going to see some samples of that later on today. And I would say, whenever certainly if you're considering developing a new application to run against the database, or if you're doing a major modification to an old one, then consider whether it should still be a green screen or batch application at all. I'm sorry, can someone just go on mute, please? Yeah, so maybe instead of remaining on green screen, change it to a web services interface. By doing that, not only are you improving the interface to the user, because now it can be used not just by people who know how to use a 3270 green screen, it can be used by people much more widely in the business who know how to use an internet browser. We had a case where previously the retail stores had to call head office in order to get some information. Now it's just a web page that they can use in store in front of the customer to find out when the next delivery of that particular electronic goods is going to be in store. Much better for the business, more efficient because it's getting the data directly from the mainframe. It's not relying on refreshes or downloads to other platforms. So the mainframe can do all this stuff, look at what the mainframe can do, and consider using it. So don't be constrained by just because it's the way we've always done it before is to do a green screen or a batch application. Look at the new interfaces that we have available to us. So this session, we're going to look at ways to improve the application performance within the application programs. So I'm going to start with a brief introduction to the URT. I say it's a brief one because there's actually a separate two-part webcast just on the subject of URTs. They're unique to Datacom. If you really want to get the nuts and bolts on the Cadre website, you'll find links to a whole two-part webcast just on URTs. It's much, much more than just a list of tables accessed by the program. It contains interface code for batch non-ideal applications, which actually establishes the communication interface to the multi-user. It has a number of processing options that affect the whole URT. It does have a list of tables, but it also has the ability to have sequential read ahead options. We're going to talk a bit more about sequential read ahead and where it might be appropriate. This could be a real boost if you are using step-at-a-time type applications, for constructs, for example, in ideal and metacobol, where you do need to trawl through large amounts of data. We can improve the performance of that using the sequential read ahead process. GSETL and GETIT. Now, if you have ideal for constructs, if ideal detects that your for construct is a candidate for this sequential read ahead processing, it will automatically change it from a for construct dynamically at runtime to use GSETL and GETIT, this sequential read ahead processing. But it can only do that if you've coded these options in here. Now, for metacobol, that's not automatic. So if you want to make use of sequential read ahead processing, you need to convert your for construct into a locate sequential and read sequential set of commands. So it's just to let you know that ideal converts this stuff automatically, metacobol doesn't. So what is sequential read ahead? Well, here we have our two regions. We've got our application region running the COBOL program or the ideal program, and we have a multi-user region. In the application region, in the program, we're going to use GSETL GETIT. As I said, Ideal will automatically do this, or a meta-COBOL, you have to code it yourself, or if you're non-native COBOL, you have to code it yourself as well. And in the URT for the table that you're going to trawl through, let's say you want to get all the customers in the entire environment, the whole of the customer table. You can code GETBLK equals up to 61440, that's the maximum you can code, that's 60K at a time. And GAMAXR equals 255, which is a special value to say it's not actually limited to 255 rows, it's going to be unlimited. It's going to get as many rows as it can fit into this 60K block, okay? So GETBLK is, instead of just requesting one row to the multi-user and get me back and do it, next row and get back, all this communication overhead. We're processing millions of rows here this time because we're transferring all the data from our customer table. Yeah? Instead of doing it one at a time, I'm going to give you a block of storage so you get me 60K's worth of data in one go, subject to a limit of GAMAXR. And we'll talk later about why you actually might want to make this lower in certain circumstances for update data tables. But in general, for read only, in most cases, you want to make it 255, which is unlimited. So always get me 60K's worth of rows. So it's going to hugely cut down on this communication overhead between the application region and the multi-user region. Instead of just getting one row, it's going to get 60K's worth of rows in one go. So when Datacom receives this, the third parameter that you specify in the URT is SEQBUFS, sequential buffers. These are buffers within the multi-user region that are allocated to help Datacom service this sequential read ahead application as quickly as possible. So here we've coded SEQBUFS equals 32. What Datacom does, it halves that value, so it goes SEQBUFS equals 16, and it goes and fills up those first 16 buffers right now. Yeah, it goes and gets 16 buffers worth of data. Now, if your data is blocked at 27998, half-track blocking, it's going to get 16 of those 27998 blocks of data in its buffers stored here, ready to send back. It's then going to send back the first 60K for your program to access it. Your program starts plowing through those 60K. There's no communication here at all while it's processing that. And it then goes and gets the next 60K and the next 60K. So now, while it's been doing that, while your application program is communicating between the GETBLK and the SEQBUFS here, the first 16 buffers, in the meantime, Datacom in the background is going back and filling up the second 16 buffers. So by the time you finish processing the first 16, it's already got the second 16. Yeah, buffer 17 to 32, and now it starts returning those. So you can see that both the application region is able to process large amounts of data in one go over here, and meanwhile, Datacom in parallel is also processing large amounts of data over here. You can see now that this is a major performance benefit for cases where it's suitable. So the pros of this are significantly faster batch sequential processing, reduce elapsed time to the multi-user doing the read-ahead processing, reduce number of multi-application communications, especially if you're communicating over an XCF environment, and possibly reduced IOs because of the very fast buffer reuse. These sequential buffers are either reserved for you or they're very quickly reused within the Datacom environment so that it's serviced there very quickly. By the time your application needs it, Datacom has already got it. Okay, that's the pros. The cons is if you code it in inappropriate situations, then it can actually hurt performance. So cases where you're getting lots of data rows that are never actually read by the program. So you start the process, you say I want to go through all the customers, but actually in your program, when you get a quarter of the way through, you find some indicator that says, oh, well, I've got the data I need now, I'm going to terminate. I found the data I want. I'm going to return to my calling program and give them the result. Meanwhile, Datacom's going ahead and reading a load of extra rows that you're never going to read. That's wasted processing, so it's actually hurting performance. Yeah. Now, that's typical when not reading the key range from beginning to end. So either saying it's a for construct with no where clause, so you want the whole table, or specifying where the key value is greater than or equal to of a start value and not specifying the end value. Yeah. So for ideal, specify both the beginning and end value in the where clause, and for non-ideal, be sure to specify the end key range value in your request. Now, that's something, again, if you've got very old COBOL programs, That feature was not documented in previous releases of Datacom, so you may find things that are doing this in COBOL GSETL processing, GSETL processing, and coding the end key range value will actually improve the performance of your overall system as well as the application. Another con to this is if you get lots of data rows holding them under primary exclusive control. Because we're getting blocks of data, if you're reading it for update, it's got to read not just one row for update, it's got to read 100 rows or 1,000 rows, however many it can fit into that GETBLK value, and hold them under its control, because you might update them in your application. So if the URT has update equals yes in a GETIT situation, all of them are locked. All of those rows are locked. So that's a case where you might actually want to specify GBMaxR considerably lower than the 255 value. You might still have to say GETBLK of 60K, so here's my communication buffer to send across between the environments. Depending on what the row size is, that may or may not be appropriate. But actually, I only want you to get 10 rows at a time. So only 10 rows are locked at a time, which reduces the contention with your other applications. Now, of course, if this is a monthly archiving program that runs on a Sunday night when no one else is using it, it might be appropriate for you to have update equals yes and GBMaxR 255. I don't care if it's locking 1,000 rows at a time, because it's at a time when no one else wants to read those rows. But if you're doing it on an application that's running concurrently with other applications that want to access this table, then typically you want GBMaxR equals 10 or something appropriate like that. Okay, next topic, URT priority. Does it really matter? Well, yes, if you're in a quiet environment, in a test environment, you're never going to be able to see this. But in a busy production multi-user environment, yes, URT priority is still very effective and very important. It is influenced by the MUF BREAK parameter, but again, modern mainframes that are much faster than they used to be, break 500 is suitable at almost all sites. This actually contradicts some stuff that's in the manuals, but I'll tell you that all the sites that I've worked with, we've tested it all, and break 500 is the right value. So even with break 500, which is the maximum you can have, what should you specify for priority in your URTs? Well, if you have separate KICS, AORs, application-only regions for your really, really critical stuff, the stuff that's got to be instant response, then I call those hot KICS application regions, and hot trusted server applications, then set the URT priority to something like 12. For normal KICS application regions and your trusted server, set it to 10. What do I mean by trusted server? Well, I mean a server that's running only applications that have been tested and verified that they don't impact performance. What we don't want is to have a server running at high priority, and any ad hoc person running an ODBC query tool can submit a monster query that kills the performance of the Datacom environment. Because remember, the way that priority works is this is going to jump the queue. The thing at the top of the list, it's going to jump to the top of the request queue within Datacom, and it's always going to be processed first. So you don't want to allow inefficient things, anything untrusted, anything that hasn't been tested thoroughly and performance analyzed and verified. You don't want to allow those to run at high priority. But your hot KICS, your hot trusted server, your normal KICS and normal trusted server should be running at higher than the default URT priorities. Your hot batch, again, it doesn't need to be run as fast as KICS and server because it's not online users sitting there waiting for it. But stuff that's on the critical path for your batch schedule, or anything that's time sensitive, it has to be completed by a specific time in the schedule, and therefore it needs to be higher priority than anything else. Set that to 8 or 9 into priority. Normal batch, this is the CA defaults, should be running at priority 7. A lot of sites are running priority 7 for everything, and you get benefits from tuning it so that your critical path and your hot online applications run faster. Similarly, so that's your default. Your normal batch runs there. Data query and any ad hoc server, because again, data query is just is an ad hoc query tool. The ad hoc queries that you run through server, make sure they run lower than batch. So if someone does run a monster data query or a monster ODBC request, it's not going to impact the performance of the mainframe database. And all your other applications are still going to run fine because they're going to be ahead of the queue in here. And anything that's really low priority, so batch data query, DBSQL PR default stuff, We run this at that level, and anything running data reporter, because typically those are not very urgent things. They need to be run, but they don't need to run quickly. Set them to a 3. That's what we have for priority. It can be a very, very useful tool in ensuring that all your critical stuff still works, but still allowing the ad hoc stuff to get done in the background. Okay, on to general programming recommendations. I mentioned this in the first session. We've got these 3 different APIs, record at a time, set at a time, and SQL. And you can mix and match all 3 of those access methods within a single program. Don't do it for the sake of it, but there are cases, for example, if you've got a big set at a time program, but you need to add an extra paragraph to it, an extra section to it that's going to do some meaty stuff, joining lots of tables together, but it still needs to run within this application program. It's perfectly possible to leave all of that with its for constructs and all the rest of it, and do the new stuff using SQL. So taking advantage of being able to aggregate that data by running it on the zip and using it SQL, and just getting back the rows you need for this bit of the program that you need. You can mix and match all 3 of them. Okay. Record at a time is not available for ideal. It's used by MetaCobol locate and read statements. It's similar to a vSAN programming API, so you have to specify the key, the key that you want to use and the key value that you want to go on. So the disadvantage of this is if you change keys or elements, then it requires you to change programs. I talked in the first session about a query you can run to find out whether your keys are used by record at a time programs. It can be very important in determining whether you can add or delete a key or modify a key. Any changes to the key will require you to change your application program. But it does provide very fast random keyed access. So if that's what you need to do in specialized applications, where that's what you really need to do, something that's just validating, does this customer exist? Yeah, I just need you to quickly locate that index entry. You don't even need to read the data. It can be very, very quick at doing that. Yeah, so there are cases for using it. It's far less used than it used to be. But each request results in a new communication to MUF. So again, even though it used to be the fastest thing on the block, in many cases it's no longer the fastest thing on the block because of the improved abilities of SQL to do the aggregating of data and just return the data you need, having done the work on the zip. Sequential Read Ahead, I've talked about this, GSETL GETIT. It's only available in batch. It doesn't work. It doesn't happen in online kicked ideal applications. It's very fast at trawling through large key ranges. You need to tune it using those buffers. We talked about that already. This end of key range, you can now specify in the GSETL. It has actually always been available, but it was never documented. So as of release 12, you can see how to do this. So revisit your old applications and perhaps put the end of key range on there. It'll run faster. But with record at a time, often you're retrieving rows that you later reject by the application in some if test within your application, or having joined to a different table using got data from lots of different tables. You then reject this whole collection of rows. So all of that work's being done on non-zip processor, so it's expensive, and we want to reduce that. So record at a time historically has been good, but it really should be only used for specialist tasks now. Set at a time. This is what ideal for constructs and MetaCobol for constructs use this. Under the covers, it does self-FR, select first record, select next record, select same record, or select, this is actually self-PR, which is release the set at the end of it, the N4, effectively. So it allows you to do the where clause. You can select on non-key fields this time, and key changes don't stop the program from running. They might impact performance, good or bad, but they don't stop it running. But the data views can only reference a vertical subset of a single table. You can't, a Datacom CBS data view, as it's known, can only reference a single table. And it's a vertical subset. It's a number of columns within that table. It doesn't do the horizontal subset within the data view. That's done by the where clause in your for construct, and it can't do the join. It can select on non-key columns, so that reduces the communication overhead because we're not retrieving rows that we can now satisfy with the where. And now the sorting and that selection is done by the multi-user on the zip, so that's better. That's a lot better. If you have old programs, we've seen quite a few of these where they did some tuning. They found out that Datacom back in the 1980s wasn't performing very well for this particular for construct, and so they took stuff out of the where clause and put it into if tests within the program, which back in those days may have been the right thing to do for that old release of Datacom. Now that everything's running on the zip on Datacom, it's almost always worse for performance. So get rid of those if tests and internal sorts that were put in there specifically to make a particular program run faster, and let the Datacom database do the work. Datacom CBS has improved in its performance and the way it does its optimization, and all of that work is now on the zip. Yeah. So if tests and internal sorts should be stripped out of programs and put it back into the where clause as much as possible. Okay. Medico, I mentioned this doesn't convert this sequential read ahead candidates automatically to GSETL and GETIT. So for that, you need to convert to locate sequential and read sequential statements within your MetaCOBOL program if you want to take advantage of sequential read ahead. What MetaCOBOL does do, which Ideal doesn't, is to allow skip processing within the set. So having established the for construct, I've actually got a for each program, a single for each program with a transmit statement in it in MetaCOBOL, which does the whole of the scrolling. So it allows you to jump to the top or bottom of the set or the relative position within the set. So scrolling backwards and forwards, I need to skip back 11 lines because that's what's happening on my screen and fill up from the bottom. All that kind of scrolling stuff you can do easily with MetaCOBOL with the skip processing that's in there. MetaCOBOL also allows you to use that CELSM. I mentioned CELSM, some of you might have gone, what's that? We've never seen that. That's select same. Why might you want to reread the same record you just read? Well, there are cases where you might need to read through a lot of data in order to find some other criteria, and only very rarely do you need to do an update. And this is a very important table that lots of other people need to access concurrently, and they need to update it concurrently, and they really don't want you locking rows unnecessarily. So you can do the for construct using a read-only CELFR, effectively the for construct without a hold statement. Then when you find the row that you want to update, you can issue a select same for that same record, but this time with update. So you're rereading it for update, just so you can update that one row, and now you move on to the next row, and that previous row is released. Yeah, so that's a specialist case where you might actually want to use select same. It's rare, but it's there. Okay, so how do we tune these for constructs that we have here? Well, our biggest free tool that's available and has been since the start of Datacom is to use the CBS trace. So in Ideal, that's the set run CBS trace on statement before you run the program. And in COBOL, MetaCOBOL, etc., if you move $, to the first 3 characters of the user information block, which is one of the parameters that you pass, that MetaCOBOL generates for you, or that you code in your native COBOL application, then that request, that for construct, will cause a CBS trace to be written to the PXX. Historically, that was to a PXX dataset, but nowadays it's typically this is out from the MUF. There's a separate thing for the PXX trace information, which gives you a very detailed trace of exactly what the criteria were from your where clause and your order by, what key it chose for the traversal, which key it chose for the ordering, sorting, and that could be a different key, and gives you lots of information about why it did that. If it had to build a temporary index, it gives you information about all of that. So manual joins for nested for means that often means that rows are returned and again rejected by the application in non-zip processing. So again, this CBS trace, if you actually do this for one of your real programs, and you might think it was only retrieving 50 rows or something like that, if you run the CBS trace, very quickly you realize, well, hang on a minute, because of this nested for construct, we're actually retrieving thousands and thousands of rows. And so now we need to find ways to do that more efficiently, and typically the best way is to create an SQL view and use an SQL statement that references that view that is doing the join on the zip processor within Datacom. Okay, temporary indexes. I've seen sites that have said temporary indexes are terrible. We should get rid of them all. There are cases where they're actually valid, but we need to identify temporary indexes, why they're being generated, and work out whether they're unnecessary and get rid of them. So when does a temporary index get built? Well, CBS examines the request, your where clause and your order by, and determines the best way to access the data. A temporary index is always built if we have a mix ascending and descending in the order by, always built in that case. It's also built if the order by or the group by is a non-key field. If we have a signed positive numeric field in the key, then it builds a temporary index for that. It will also build a temporary index if there's a better key that satisfies the where clause than the specification in your order by. Yeah? So even though you might think you've specified your where clause to match a key, and it does match one key, sorry, the order by to match a key, yeah, because the where clause is subtly different, and that where clause matches a different key, it might choose to use that key for the retrieval and then sort it using a temporary index. So now sometimes the temporary index is not a bad thing. Again, if it's only built very rarely, perhaps on a Sunday night when they're doing an archiving run, that's actually better than having to maintain a permanent key for this index. But if it's being created often, or if it's creating very large temporary indexes, then we really need to identify those and eliminate them. So here's some examples of getting rid of unnecessary temporary indexes. The mixed order by with both ascending and descending. Here we have a where clause, which is selecting on these 4 columns. Yeah? 3 of them are specified as equalities, and the last one is specified as greater than. Okay? The programmer has coded to order by, and he's matched the key here: effective date for FGI in price class and all in bracket code. Okay. But this last one, he wants it in descending sequence. But because these 3 are specified up here as equalities, they can only have one value. So there is no difference between ascending and descending because they all have one value. You know, the ascending descending only actually applies to this last column because these 3 are specified as equalities. So simply by moving the descending up to here, so now we're saying descending all 4 of them, we're going to get exactly the same data in exactly the same sequence, but we've eliminated the temporary index. Yeah, that was an unnecessary temporary index. We just got rid of it. Great. Okay. Sign numeric fields and key. Columns, I say, and key. There's a rule from cod and date, and so that's what the SQL create table does. Okay. If you have used create table to do that, but you're defining columns that can never have negative values, then you can specify them as the DBA can change it to specify as unsigned. They can change the definition of the column to unsigned afterwards. So it's something for the DBA to do. If the column has to be signed for other reasons, perhaps it's loaded up from an external interface and we really want it to be a signed column within the database, but we know it can only ever have positive values, then again the DBA can update the type numeric attribute to P, which means positive only. And again, then Datacom won't build a temporary index for it because it knows it can never have negative values. Okay. If the program does have, if the column does have negative values and it's part of a key, then the DBA should consider using the data-sensitive attribute. So the way that Datacom then builds the index for that table, for that key, means that it can be used without having to build a temporary index. So these are all things that you can do if you have fine numeric columns in your keys. Right. Now, determining that best key for use. I mentioned this. CBS dynamically chooses the best key based on the where and order by clauses. Actually, it chooses the traversal key based on the where, and then it looks at the order by afterwards. So I've seen programmers code order bys trying to so-called force CBS into choosing a particular key. That was true in very, very early versions of Datacom, that you could actually influence CBS decision. It's no longer true. CBS works out the best policy, the best key to use based on the where clause. So be very careful when trying to second guess it. You sometimes come across programmers who've been around for ages and they say, oh no, we do this to give Datacom a hint. It's not a good idea. So if you find cases where you've got this order by in there to so-called force CBS to do something, definitely run a CBS trace using that set run CBS trace on or $$ in the UIB to check that your assumption was correct and make sure it is picking the key that you expect it to do. Otherwise, take the unnecessary order by out. In fact, I have a general rule. It's not a golden rule. The general rule is don't code the order by unless you specifically need the data in that order. Yeah. If your program doesn't care about the order by, take it out. Yeah, if it doesn't specifically need it in there, and let Datacom retrieve the rows in the fastest method and return it back to you in whatever sequence it sees fit. If there are two similar candidate keys, then CBS can do the statistical population counting, and it can change that key selection at runtime, even between two different executions of the same program, just with the different data value going through. Datacom can suddenly switch to using a different key, and you might get the data in a different order. Okay. So in the following example, the order by matches the native key, but there's a better key matching the where clause. So here's the code we had before. Again, there's a bunch of columns specified as equalities, and this next one is specified as a greater than or equal to. And they coded an order by that matches one of the keys on the table.
So, but Boulay can.
Excuse me, someone is not muted. Please, everyone mute. We can hear somebody shuffling papers and talking in the background. Someone is not muted. Please do *6. Thank you.
Thanks. On the right-hand side, we can see the corrected for construct in here. So what I've done, I've moved the source code to a different location. It's moved after the current week, which makes no difference because both source code and current week was specified as equalities. Again, it's going to retrieve the same rows in the same order. Inserted an extra column in here, which again is specified in here, and that does now match the key. Yeah? So it's now a direct selection because in this one, the where clause and the order by clause chose two different keys, so it had to do statistical population counting. With this one, it's now doing a direct selection. Again, it eliminated the unnecessary population counting and temporary indexed without changing the data because these were all specified as equalities. Okay, another couple of where clause just general tips. Avoid the not operator if feasible. It's more efficient to say where active equals y rather than where active is not equal to n. You might think they're both the same thing. It's going to retrieve the same rows because the only values we've got for the active flag is yes or no, y or n. But here, it's having to check all the values less than n, all the values greater than n in order to satisfy the request. So it's actually better to code an equality than an inequality where you can do so. Specifying alternatives to or for a field. Use a range where possible. Here we've got where quantity equals 3 or 4 or 5. Change that to where quantity greater than or equal to 3 and quantity greater than or equal to 5. That's a single traversal. This is actually 3 traversals it will do of the table in order to find the 3 different values internally. So it's more efficient to use a range if you can. And only convert it to an if in very special circumstances. Again, now, especially because of the zip, it's incredibly rare that having an if statement instead of a where clause is actually good for performance. So I would strip these out in almost all cases, and anyone who insists that they must have this thing, then do a test of the application with an if and having it as a where clause, do the CBS trace, and measure the performance exactly. Yeah. Right, SQL. As I said, I recommend that all new applications to be written using SQL. With portfolio simplification that Kevin talked about on Tuesday, every site now has SQL. Even if you didn't have SQL in the past, you're entitled to it now. Your DBA should be, if you didn't have SQL in the past, should be looking to implement SQL and make it available to you. It's an industry standard syntax. It's much easier to hire SQL programmers than to find ideal and meta-COBOL programmers. It allows all the joining and aggregation and formatting to be done within the multi-user. And all of that work can be done on the zip. Only the I/O is done off the zip. Yeah? So huge amounts of processing can now be done on the zip by using SQL. It keeps your application very small, very simple, very efficient. Rather than having to do nested for constructs to do multiple joins between multiple tables and do the joining effectively within your program, you just have a single SQL statement. In most cases, you only need 1 or 2 SQL statements in the whole program against a joined view that does all of that aggregation and just returns the 100 rows that you really need to process within your application. It minimizes the communications overhead. The SQL prefetch, I talked about sequential read ahead processing. SQL prefetch also works for online programs. So again, for online applications, it's even more efficient. Okay.
Hi, Owen. I'm going to mute everybody, and because I don't know what to do, and then you need to do #6 to unmute just yourself. Okay, so I'm going to do it right now. *5.
Okay.
Okay.
The leader has muted your line. To unmute your line, press #6.
I hear us. Owen, can you hear me?
Yeah, I can hear you. Can you hear me?
Yes. Okay, perfect. Keep going.
Okay, great. Right, I'll carry on. Right, thank you, Nancy. So SQL prefetch works perfectly for KICS requests too. So it's, again, much more efficient than using full constructs. Use SQL for that. And if you've come from other SQL platforms and you find a piece of SQL syntax that's missing in Datacom, please let us know, because the Datacom development folks really want to focus on delivering enhancements that actually provide benefit to you, the developers. So they don't want to go through the whole SQL syntax manual and develop everything. They haven't got time to do all that. If you tell them, oh, I really need XYZ function that I could do in Oracle or somewhere else, and it's not in Datacom, please let them know, and we'll look at getting that included in the SQL syntax for you. Okay. Another great advantage of SQL is the ability to do constraints, which can be used to implement the business rules. So again, this all runs on the multi-user. So rather than you having to check, I'm about to delete a customer, I need to go and check whether he's got any outstanding orders and not allow him to delete the customer because he's got outstanding orders. This can be defined as a reference to an integrity constraint, so that the Datacom system blocks that kind of delete. You can just go ahead and say, I'm going to try and delete. And if I get an error, then I handle the fact that he's trying to delete a customer who has outstanding orders. Yeah. So again, simplifying your application code, greatly simplifying your application code, and allowing this work to be done in the database, which runs on the zip. Yeah. So it makes it faster for you to develop new applications, and it's faster for the system to run it that way as well. Okay. Similarly, as well as referential integrity constraints, you can also define domain constraints. So a particular column can only have certain values. Similarly with deletes, if you're deleting orders, we've got the order header and we've got the order lines and maybe some ancillary tables in there. Just by deleting the order, delete cascade will do all the other deletes for you, simplifying your application, making it easier to maintain, quicker to develop, and it all runs on the zip. Another feature, new Datacom feature, is the SQL cache. I think Kevin may have mentioned this on Tuesday. So you can improves the case where you're doing repeated dynamic queries. If you're using dynamic SQL or Datacom server and things like that, that significantly improves the performance of SQL because it's caching the requests, the SQL statements for you. It can also be used as a tuning tool to find out what SQL statements have been executed by a particular long-running request. Some other SQL tuning tips. What am I doing for time here? Oh, crumbs. Okay. So some simple where clause predicate tips. I talked about improving ORs. SQL in versus using SQL or. This case, we've got a where column name is in 5 and 7. That's actually usually more efficient to code where category type is 5 or category type equals 7. Because of the way in works, that's not passed down to CBS as one of the selection predicates. So it's only resolved after Datacom has retrieved the rows from the data area, whereas the OR predicates are passed down to CBS. So usually OR is better than in. There are cases still for using in, particularly if you're doing a sub-select in the in, that's fine, no problem with doing that. But where you've got the opportunity to change a simple in like this to a couple of ORs like that, OR is better. OR versus between, this is the same rules we had for ideal in full constructs. Here we've got the category type, and it is a range, it's 5 or 6 or 7. 5 or 6 or 7 is usually faster than coding as an in. But faster than that, much faster than that, is using between. Because again, this is a single traversal of the data. Between is an inclusive thing, so between 5 and 7 will get you the same data, but it will get it faster. Usually between is faster. Index cardinality stats and row counts, very important for the performance of SQL. Because SQL, in many cases, chooses the join order at runtime, or can choose the join order at runtime based on statistics that it has available. and certainly does that for the selection predicates that it's using. It's very important the statistics that Datacom has for SQL to use are up to date. In DB2 terms, this would be equivalent of run stats. So you should run report area equals IXX with the DBID, a type G report with update equals yes on a regular basis. We do it weekly for all our tables. And similarly, you should run a retix with key name equals asterisk setar, which resets the row count in the CXX. One of the recent enhancements that greatly improved the performance of select count asterisk from table name, where you don't specify a where clause, is that now just gets the result set, the result of that directly from the CXX. It hugely improves the performance of select count asterisk because it just gets it straight from the CXX. It's just one read rather than counting up all the rows. But if you don't have that, if you don't keep that accurate, then you're going to get the wrong number out of it. Now, Datacom's improved the way that it handles that so that the CXX row count doesn't go out of step very often. But particularly if you have UAT environments that you copy using, you refresh them using DAS utilities, DFDSS, then you've restored all those data areas in there. The CXX you don't restore because the CXX typically you don't restore when you do those refreshes. And now your set counts in the CXX are all wrong. And so your select count asterisk actually gives you the wrong result, a dramatically wrong result. So this retix asterisk setar will reset that value in the CXX. So it's important to do these on a regular basis to make sure that all the values that SQL uses for its optimization and the select count asterisk are accurate. There have been several enhancements to SysMessage recently to make it much easier to understand. They're moving it effectively to much closer to the sort of things that DB2 Explain does. Previously, various predicate messages were written to the PXX where developers typically didn't see them. Now, if you do a select asterisk for SysMessage where the plan name is your plan name, having turned on messages for your plan, if you set the plan off at MSG equals S for summary, then this gives you a very good explanation of the optimization that it went through to tune your query, so to execute your query. So very useful tuning tool. Some final COBOL tuning tips. The COBOL string and unstring functions with pointers are very efficient. Caching versus internal arrays. Again, typically older applications, I've seen people preloading in the initialization section large quantities of data into arrays and then trawling through those arrays every time they process a transaction, input transaction to try and find the rows. If you're using direct access to an array, so you've got a 4-byte cost center code, let's say, which you preload, and your instruction in COBOL is if input transaction brackets cost center code equals Y to say does it exist or not. That's a direct access to that specific element. That's very fast and efficient and great. I have no problem with that at all. But if you're reading an input transaction and then doing a loop going through searching an array, particularly as a large array for each one, that's CPU intensive. And again, this is running in the application region, not in the multi-user region, so it's running on the chargeable CPU. Much better to do that work in the database using a SQL to do the aggregate and work out all that information, just return the rows you need, because it's all running on the zip. When you're coding evaluate predicates, if you're using the evaluate statement in COBOL or the select statement in MetaCOBOL or the select statement in Ideal, always code the most used ones first. So it hits the when that matches most often first. It makes sense, but often people miss this. So again, you're not testing lots of things before you get to the value. I've seen programmers always code them in alphabetical sequence. Well, why? That's not logical for performance at all. CBL OPTIMIZE is a major performance benefit in COBOL. If you use the IBM COBOL II, sorry, not COBOL II, IBM Enterprise COBOL Optimize function, it's very, very good now. It does stop the debugging working. So typically, there's a case here we have sites that do a dual compile. They have a compile with Optimize that they run normally for optimal performance in the 99% of the times when it runs perfectly, and they have a second copy of the load module without Optimize that they can swap in and use that instead when they need to use the debugger. So it can be a very useful thing here. If you are looking at Enterprise COBOL 5.x and beyond, this is a huge step change in COBOL II. It fully exploits the new architecture levels. within the machine. So it can, things that used to take 100 machine instructions to do can now be done in one machine instruction, and the new version of COBOL will take advantage of that if you code the architecture level as your compile option. Make sure you choose the highest level that's supported by your hardware, but don't forget your DR site. If you've got a Z13, don't code architecture level for a Z13 when your DR site is still running a Z10. Otherwise, when you have a disaster, you're going to have a real problem because none of your programs are going to work. So do consider that. But this is a major enhancement for new versions of COBOL if you are going to Enterprise COBOL 5. Some ideal programming tips.
Owen, this is Dale.
Yes.
I know you have a substantial amount of material left, and we only have like 5 or maybe 10 minutes at the most. So
okay.
One idea we've thought about, if you are available, is to, at some point we will finish this session in time to do the next, but then schedule a subsequent session at 1 o'clock Eastern. Would you be able to do that?
Yes, I can do. Do you want to do that? Yeah. Okay. Right. Okay. Shall I break now then? That gives people a chance to ask some questions.
Sounds good.
All right. So we'll do. For everyone on the phone, we'll put out another link to the groups that basically will have a link for a application tuning part 3 at 1 p.m. Eastern time, which is 2 hours from now. So that way we can finish the session and not be rushed through and let Owen give us the details we need for the programming.
Okay, thank you.
Right.
So let's move to questions. If anybody has questions for Owen at this point. You need to do a #6 to unmute yourself before you have a question.
So we're waiting for everyone to put their questions together, Owen. I did have a question for you. I don't know, have you looked at, when you started out the presentation, you were talking about the GETIT GETIT and, how good it is, but also how people can do bad things by getting lots of rows that they actually don't use. They're doing, that sort of processing. Have you seen the new feature in 15.1, the new messages around, I think it's the VB153I message will actually show you if they had what I call unrequited love, where they loaded records into the MUF but not read them?
I must admit, that feature has passed me by. I will now investigate it. That's a good thing for me to learn. Thank you.
But it's brand new. It shouldn't be anything that, I doubt that very many people have caught this, but we put this in. It's under the 15.1 June 10th enhancement set. There are 3 new messages that give you information about that read, the get block and GETIT GETIT processing. And there is one message, 153I, that actually tells you if you had a number of rows that we returned, but you did not read them. And basically that gives you that opportunity to see, if you search for that message, to see if you have some programs that maybe read several thousand rows into a big buffer but never read them, never actually used them. So MUF did all the work, but you never actually used what he gave you. And I will tell you that's because you and I have been poking Joe in the ribs for the last 20 years saying about how great CBL GETIT is, but how bad it can be if someone misuses it. So I just
that's a great new feature. Thank you very much for that. We will definitely use it.
So everyone on the phone, questions for Owen so far?
Okay, then I'll close this one up. I will try to quickly add a new session for 1 o'clock Eastern Time, 12 o'clock Central, and then at the top of the hour, I will bring up the WebEx for our next speaker today.
Thank you, Owen.
Thanks.
Great. Thanks all.